All right, we're on going to start on the bottom of page 326 today. And you're going to be using angle bisectors today. To solve segment and angle problems. You're using angle bisectors to solve segment and angle problems. So there's a definition on the bottom of 326 that says the bisector of an angle is a locus of points equidistant from the sides of the angle. So very simply, if you have an angle, and this angle is ABC, an angle bisector, they call it a locus of points. Well, if you connect a locus of points, you get a ray. So if you have a ray that starts at point B, and it goes up and to the right in this direction, and you put point D on it, an angle bisector cuts the original angle ABC in half. It cuts it into two equal angles. So in this case, BD, ray BD, is an angle bisector. Then on the top of the next page, 327, there's an angle bisector theorem. And what the theorem states is that if a point is on the bisector of an angle, then it is equal distance from the sides of the angle. What that means is that any point along BD is the same distance from the side or from the sides of this angle that it bisects. So this piece right here is congruent to this piece. All right, if the angles created by BD are the same, then the distance from the side is the same. You okay with that? The converse of this theorem states that if a point is equal distance from the sides of an angle, then it is on the bisector. Right, so that's the theorem both directions. The theorem and then its converse. So if a point is equal distance from the sides of an angle, then it is on the bisector of the angle. So there's some examples. There's example number 3 on the bottom middle of page 27 there. And you're asked to find each measure. And you may be better off just looking at the diagram than trying to draw it, because it's going to take you longer to draw it than it is to actually do the problem. So if you have to find each measure, and you're looking for XY, and you've got this picture. Now, in this picture, let's see, where's XY? Here's X, here's Y. This angle in here, both of these angles are 41 degrees. So if those two angles are the same, then this ray coming out of here, ray ZX, what's that called? It's an angle bisector. And any point on the angle bisector is the same distance from the sides of the angle. So if this distance here is 2, how far is it from X to Y? 2, good. In that next example, you're asked to find the measure of angle JKL. And here's your picture. We got point L here. Now, here's what you're given in this picture. You're given that the distance from this left side of the angle to L is the same as L to the right side of the angle. So if L is the same distance from both sides of the angle, then what is it on? What is it sitting on? What's it called? What's K to L called? An angle bisector. So it bisects this big angle down here. So if one of these angles is 37 degrees, and you need the measure of JKL, well, here's J to K to L. It's 37 degrees. Everybody okay with that? 37 degrees. All right, in that third example, you need S to P. And here's your picture. You got point S. P is down here. And you're told that these two angles are the same. So if these two angles are the same, what is JS called? A what? An angle bisector. So if this segment is 3x plus 5, and this segment is, I wish I could read, what does that say, 6x minus 7? Thanks for your help. You need to find S to P. That's this segment right here. So what do you know about 3x plus 5 and 6x minus 7 if S is on the angle bisector? They're the same. So 3x plus 5 is equal to 6x minus 7. You can subtract 3x from each side. So 5 is equal to 3x minus 7. And then add 7 to each side. 12 is equal to 3x. And divide each side by 3. And now 4 is equal to x, right? But you need S to P. So S to P is this expression right here, the 6x minus 7. So we need 6 times 4 minus 7. 6 times 4 minus 7, 17. Very good. Everybody get the idea? Anybody have any questions?
No.
Are you sure? Yes. All right, then your practice for today is going to be on page 329. You don't need to. 5 through 7. And then over on the next page, 21 through 26. You've still got 8 ALEKS topics this week. And I have posted page 330 and page 329 to focus. Okay, so if you don't get the problems done in class, those pages are on focus where I put the notes all the time. Questions? All right. Get to work.